Hi, welcome back. We're going to finish this side of homework 14. Let's do it. So it says the figure shown shows lines R and P intersecting to form angles number 1, 2, 3, 4, 5, and 6. All three lines line in the same plane. Based on the figure, which of the individual statements would provide enough information to conclude that line R is perpendicular to line P? So they don't really look perpendicular, and they're trying to do that on purpose. So what I would suggest is actually making it look the way it's supposed to look. So it's based on the figure which statements would be enough information so that we could conclude that these two lines meet at a 90 degree, okay? So that would mean, it looks to me like if angle 1 and 2 added up to 90, then that would be a box. If angle 5 and 4, any of these, right? This would be a box. If angle 5 and 4 added up to 90, that would make a box and lock that in. So that one I like. Angle 3 and 4, same thing. That would look like this one. If angle 3 and 4 added up to 90, that would make a box. And once you get one box, that locks in the rest of the 4 boxes. So I like that one. If 1 and 6 added up to 90, that would be this box. So I like all these. If angle 3 and angle 6 were equal, like if this was, I don't know, 62 degrees and that was 62 degrees, that doesn't tell me that that's a box. That's just some type of information. If they told me angle 6, just this angle 6 was 90, that would be enough to lock it in place. If they told me angle 2 was 90, then that's not enough to lock it in place, because notice I'm trying to make R and P be 90. So if that's 90, that's N and P being 90, so I don't like that one, okay? That's an interesting question. Let's take a look at this last one. So it says, match each term with its definition. A portion of a line consists of 2 points and all of the points in between. So a portion consists of 2 points, like let's say point A and point D, and all of these points in between there. That's feeling like a line segment. Let's talk about the next one. A connected straight path that has no thickness and continues forever in both directions. That sounds like a line. There we go. A connected straight path that continues forever both to the left and to the right. Okay. C, a figure formed by 2 rays with the same endpoint. A ray, an endpoint. A ray, an endpoint. That is an angle, folks. A ray, an endpoint, a ray, and connected by the same endpoint. C is an angle. D, the set of all points in a plane that are fixed distance from a point called the center. That's our circle. Sounded like they were being sneaky, but the set of all points that are a fixed distance from one point called the center. That's definitely a circle. D. All the points that are the same distance from that center is a circle. E, a portion of a line that starts at a point and continues forever in one direction. That's got to be our ray. Okay, so it starts at a point and continues forever in one direction. That's a ray. Lines that intersect at right angles. So lines that intersect at right angles happen to be called perpendicular lines. Okay, F. A specific location that has no, yeah, that's a point, right? It doesn't have any thickness or width, So this last one must be H, lines that lie in the same plane but don't intersect. Parallel. Now I'd probably want to define it even more so, but parallel lines, if they are in fact in the same plane, would not intersect because they have the same slope. Okay, so that is it. Thanks for joining me. See you guys next time.